Hey everyone, this is Mrs. Wade, and I'm going to walk you through the first part of the muscular system. So, here with Objective 1, the first thing we really need to look at are these different shapes of muscles. And this might be information that causes you to kind of think, well, why is this important? And when we elaborate on this information, you'll see that understanding the shapes of muscles really help you understand how the body moves when that muscle contracts. And so here we have three different basic muscle shapes. We have circular, fusiform, and convergent. And what you need to know is you need to be able to visualize what these muscle shapes look like, as well as some examples of what each of them are. I'll start off by kind of defining what each of these shapes are, and then we'll look at examples because it's really helpful to see an example with the definition. So a circular muscle is going to have the fascicles, and remember that fascicles are the organized bundles of muscle fibers. And remember that a muscle fiber is another way of saying muscle cells. And if you think of muscles of kind of having this stripy appearance, that's the visible collection of those fascicles. So you can imagine in a circular muscle, the fascicles will be shaped in a circular fashion. And so that's not too bad. When we look at a fusiform muscle here, fusiform means that the muscle is going to kind of taper at both ends. So I think when most of us, if we were just to draw a muscle, we'd kind of draw this football-shaped form. That's what a fusiform muscle is. And then a convergent muscle is going to be something where we see the fascicles converging to one point. So let's look at some visual examples. Here are some examples that I'd like for you to draw in your lab manual and study. This comes from our textbook. And here we have a circular muscle. You can see that these fascicles go in this circular arrangement. And we often see circular muscles in areas of the body that will control an opening or a closing of something. You'll learn about sphincters within the body throughout AP 1 and 2. And so circular muscles are often referred to as sphincters. One specific example of that would be the orbicularis oris, and of course that would control the opening and closing of our mouths. Now right here in the middle we have two different fiber arrangements, and these two fiber arrangements will kind of be some specific examples of muscles that you might find within that fusiform muscle shape. And so here, within the rectus abdominis, we have a parallel fiber arrangement, meaning that those fascicles are parallel to one another. So at the bottom of your lab manual, when you're filling in that those two circles there, you would want to make sure that your parallel fibers run along the length of that muscle. You can see how those two ovals there are elongated and they taper at the ends. That represents that basic fusiform shape. So for the parallel muscle, you'll want to make sure that those fibers are parallel. Here we show you that the rectus abdominis is an example of a parallel fiber arrangement. And then next to that we have pinnate or pennate. Pinnate refers to leaf-like. Pennate refers to the fact that we have fibers on either side, so it kind of looks like a feather or a leaf. So we have fibers that are going to go towards a central stem-like area. Now for muscles, that is often some type of connective tissue. And so the point being, on the pinnate or pennate, again, you'll see either here in this example PE, in your lab manual it's PI. I've seen both spellings. What you'll want to do is draw a piece of connective tissue down the center of that pinnate oval, so lengthwise. So one one line down that kind of runs down the length, and then you'll have your fascicles, your fiber arrangements, going at an oblique angle, just like this. And I think this rectus femoris example right here is a really nice visual aid. And then finally right here, for the convergent fiber arrangement, you can see the example we have here is the pectoralis major, and that these fibers will converge towards a common point. So for this first objective, make sure you can draw out those fiber arrangements and that you know some examples of those specific fiber arrangements. Okay, so moving on to objective 2, we'll look at some definitions, and you will need to know these definitions. We have some Quizlet card sets that can help you fill this in, but I'd like to draw your attention to a little bit of variation on these definitions that we'll find in the textbook. Okay, so historically when you see the origin, you might think, oh, that's the less movable attachment, and then the insertion is the more movable attachment. But if you're anything like me, you know, those definitions are kind of easy to memorize, but then I find myself years later asking myself, okay, what does that actually mean? So I've found that these other definitions are a bit more descriptive, and I really think they're going to help you learn these parts of the muscles a lot better because they're a bit more logical. So here, using this example, you'll see that we have some terms: superior and inferior attachment, proximal attachment, distal attachment. And so let's start with the origin. Remember, in the skeletal system, we broke it up into the axial skeleton and then the appendicular skeleton. Remember, the axial skeleton is what we found midline. It's the skull, the vertebral column, and we did have the bones of the thorax. And then the appendicular skeleton is basically everything associated with the extremities and how those extremities attach to the torso. So for your origin, what I'd like you to learn is that if we're talking about the axial skeleton, the origin, excuse me, is the inferior attachment. So this term inferior attachment right here is going to be the origin of a muscle that will be on the axial skeleton. If we are on the appendicular skeleton, the origin tends to be the proximal attachment. Remember, proximal meaning closer to the point of attachment. So that makes sense that if we are looking at a muscle on the appendicular skeleton, we would use the term proximal. So let's now look at the insertion. For the insertion, if we are talking about the axial skeleton, the insertion tends to be the superior attachment, meaning the part of the muscle that is higher up or closer towards the top of the head. And then on the appendicular skeleton, it would be the distal attachment. So superior and distal will go with the insertion terms, and then inferior and proximal are the origin terms. Let's look at a specific example. I know that that was kind of wordy, but after you have that written out and then you look at an example and kind of talk through it, you'll say, oh, okay, that's why we called that the more movable or the less movable attachment. So here in the book, we have the biceps brachii as an example. So remember the origin, well, think to yourself, first of all, step one, okay, I'm on the upper extremity. What skeleton is that? That is the appendicular skeleton. Okay, so appendicular skeleton, I'm going to be using proximal and distal because I'm talking about a limb. And so we said the origin tends to be the proximal attachment, which would be up here. And then the insertion tends to be the more distal attachment. Let's go back to kind of the old school or more simplistic definitions. we'd say, okay, the origin is the less movable attachment, the insertion is the more movable attachment. Well, when this biceps brachii contracts, this part, okay, of the forearm is going to move and come closer to the shoulder. So you could see that this end didn't really move, the less movable attachment, and this end did the moving. It's the more movable attachment. The action describes what a specific muscle is doing. It's the primary function or movement. So if we were to look again here at the biceps brachii, we can say, okay, what does the biceps brachii do in the body? Well, when the biceps brachii contracts, it's going to pull the forearm up towards the arm. And so we would say that the action or the primary function or movement of the biceps brachii is to cause flexion at the elbow joint. We will get a lot more practice with assigning actions to body parts as we move farther along within the muscular system. All right, next, I like to go over a term called the agonist. And the agonist, as you can see here, is called the prime mover, which means when we are talking about an action in the body, the agonist is going to describe or be assigned to the muscle that performs that action. So for instance, in the last example when I said, when I showed here the biceps brachii, if the action is flexion at the elbow joint, then we were to say, what is the agonist of that action? We would say the agonist is the biceps brachii because that is the muscle, the prime mover that causes that movement. Then we have another term down here called the antagonist, and the antagonist, which very similar in literary terms, is going to be the opposing muscle. So in literary terms, the antagonist is normally the bad guy. It doesn't always have to be a bad guy, but it's kind of the character who's thwarting the plans of the hero or the heroine. And so as we relate that to this chapter, I'll want you guys to learn these muscles in pairs. And my students will hear me say a lot, whenever you can get double your money for your study time, do it. And so the pair of muscles in this area would be the biceps brachii and then the triceps brachii. So while the biceps brachii is causing this action right here, as we see there, the triceps brachii, they haven't drawn it out here, but this is where it is opposing this action. So in this action right here, flexion at the elbow joint, and if I were to be 100% correct on an exam, I would say flexion at the right elbow joint. There's that right and left coming back to haunt you. Okay, we would say the agonist of that action is the biceps brachii that's causing it. Well, what is the antagonist? What is opposing that action? That is the paired muscle, the triceps brachii. If we were to just invert all this information, so why do I want you to just learn this in pairs, even these definitions? It's because when you learn it one way and you know it's a pair, all you have to do is just invert the terms to learn the other set of terms you have to know. So for instance, if we know that in this movement right here that we see in this example, flexion at the elbow joint, if we know the agonist is the, say the answer to yourself, hopefully you said biceps brachii, and the antagonist is the triceps brachii, then we could flip that. So the opposite of flexion is extension. So if we were to extend, what do you think the agonist of extension at the elbow joint is? That would be the triceps brachii. So then think to yourself, okay, what is the antagonist of extension at the elbow joint? Hopefully you're saying to yourself, okay, I just invert all the terms. The antagonist, if I were to bring my arm back, my forearm back down like this, that's the biceps brachii. And there you go. This is going to be a study tool that will help you a lot when you are having to learn all the other terms we have for you in this chapter. And then finally, we have this term synergist, and a synergist is going to assist the agonist. A lot of times, a synergist will stabilize the origin. We also call these fixators, meaning they will kind of stabilize the joint so that the agonist can perform at its full potential. All right, so when we get to this part right here, I feel like we need to kind of pause because we need to know what extend or hyperextend means, what it means to flex, extend, abduct, adduct. And I mentioned a couple of those words up when we were talking about these definitions here. But let me show you a really useful table we have in the textbook before we come back to this. Okay, so here we have this super useful table, 9.5, the movements of synovial joints. And you might be saying, well, this isn't even in the muscular system chapter, but it actually kind of ties together the skeletal system and the muscular system. So here you'll see, you heard me say flexion and extension, but all of the other terms you have to know will be within this table right here. So I would find this, again, as table 9.2, movements at synovial joints. I'd put a bookmark there, or at least find this and copy down these definitions, because we will see these terms over and over again. Remember, I also said that it really benefits you to learn these terms in pairs, so that if you learn it one way, by default, if you were to kind of invert the terms, you would know another set of information. So whereas flexion is going to be decreasing the angle between two bones in the AP plane, and the opposite is extension, by default you would just kind of invert this definition and you would say, okay, well, if flexion is decreasing this angle, therefore extension has to increase the angle. So let's just take a moment. Do this with me, okay, wherever you are listening to this video, and straighten out your right arm. What I'd like you to do is notice that when your arm is straightened out, it is creating a 180-degree angle, a straight line. Okay, now flex your bicep. Okay, and it's kind of like, making that motion when we say, okay, everyone flex, and you just kind of instinctively bend at the elbow, and now your hand or your forearm is closer to your brachial region. What have you done to that angle? Well, if we started at a straight line, 180 degrees, and then you flex at that elbow joint, now let's just say you created a right angle, and you've created now a 90-degree angle. 90 degrees is less than 180 degrees. So what you've done is we've kind of taken this really wordy definition. Okay, angle between articulating bones decreases in an anterior posterior plane. Whew, yeah, that makes no sense to us when we first read this, right? But when we kind of walk through it and we use words that we're more familiar with, it makes a lot more sense. So you can see that when we flex, we are decreasing that angle. We went from 180 to 90. So remember, I told you that the opposite term is simply the opposite. So if you were to extend or straighten out your arm, what have you done to that angle? We started at 90 degrees. Now go ahead and straighten your arm if you haven't done so already. Now you've gone back to 180 degrees. 180 is greater than 90. So you have increased that angle in the anterior posterior plane. Now, what does this last part mean? Well, remember, our starting point is always anatomical position. So if you were to stand and be in anatomical position and do that motion, your hand, or excuse me, your forearm would be moving along the AP plane. It would be moving kind of like in a forward, backwards position along that sagittal plane. So I won't go through all of these, but I highly recommend that you do this in lab and also in your study time. Don't just read these definitions. These definitions are kind of crazy. Read them, but then actually do them. And if you apply that kinesthetic learning modality to your study time, you are much more likely to get these definitions so much better than if you just read them in a list. And I promise you, you will have to know all of these movements as they relate to the muscles we have to learn in these next two chapters. All right, so now going back to this part of the lab manual, I'll walk you through the first one, and then I want you to use your knowledge after you've looked at that table to fill in the rest, or certainly, when we're in lab, ask about these. So to flex, remember that's the example we just went over, a muscle must be placed anterior to the joint. So think, when we flexed at the elbow joint, where's your biceps brachii? It's in front of or anterior to that joint. So to extend or hyperextend, the muscle must be on the what? Remember, this is a word pair, so you'll simply use the opposite term. What is the antonym or the opposite term of anterior? Posterior, hopefully, is what you said. So go through that same kind of logic as you look through these examples here. For objective 3, this one I highly recommend that you kind of get up and you actually replicate what you see on the page. And you can see that you'll have 2 blanks here that you need to fill in. The first blank is going to be the actual body movement, things like flexion, extension, abduction, adduction, eversion, inversion, things like that. Those are those terms that come from that 9.2 table that I showed you just a moment ago. The second term will be the body part or the joint. Now, depending on what the preferences of your instructor, you may hear either. My personal preference is to say, instead of the, I personally like to say at the, and then instead of a body part, I put the joint here. The reason why I personally like to do that is just because it's hard to mix up joints. For instance, let's take a look at this example right here. So if we are starting here and we're going inwards like this is called adduction. And if I were to, let me go ahead and zoom in here. If I were to be very specific, I would say this is adduction at the, and where's this movement happening? Well, look at that little hinge right there. It's moving at the hip. So my full credit answer would be adduction, because we're adding back to the midline, adduction at the right hip. Okay. Now, if you were to use of the, you would say adduction of the right thigh. And it's because this part of the lower extremity is connected to where that movement is occurring. A lot of times, I will see students say something like adduction of the right leg. Now, why is that incorrect? Okay, maybe ask yourself, if you're not sure why that's incorrect, maybe ask yourself, okay, well, what is the, or where I should say, is the anatomical leg? Remember, that's this part right here. Think about your knee joint right here. Do you want your anatomical leg to adduct? Owie, no, because our knee joint is a hinge joint. And we're only going to have movement along the anterior posterior plane, or kind of front to back, right? And really not much anterior, because we don't want to hyperextend at our knee joint. When we're talking about the anatomical leg, remember abduction, adduction is that lateral motion. So do you want lateral motion down here? Ooh, no, I don't think so. And so, lay people call this entire thing the leg, and that's fine. But remember, in A&P, we have learned the anatomical terms for these areas, and that is just a real common mistake I see. And so really that's an incorrect answer. And so just If you're going to use the of the and a body part, just please make sure you are using the correct anatomical term so that you don't miss any credit. But either way you want to learn it, whether it's at the hip joint or of the thigh, technically both of those answers are correct. Just consult with your instructor. Ask him or her what preference they have, or maybe they could go through other examples just to help you kind of master these body movements. For this figure right here, this is just meant to be some advanced practice. You'll see that many different body movements were required to turn this figure into this contortment right here. So this is just meant to kind of get you thinking about from anatomical position what movements had to occur in order to end up with this shape right here.